Hey there! Today, we're going to unravel a tricky physics idea, not with a bunch of equations, but with a simple story. So let's begin our tale of two forces.
So, have you ever heard the terms electric field and electric potential and felt like it was just a confusing riddle? You're not alone. I know they can sound a little intimidating.
And you know what? It is completely okay to feel that way. Seriously, this is one of the most common spots for people to get a little stuck in physics, but I promise you it's so much simpler than it seems. So let's just push the textbooks aside for a bit. We're going to uncover the secret behind these concepts by following a little character on a really cool adventure. Okay, chapter 1 of our story. It all begins in a world of forces you can't see. Our first chapter is about something you can feel but can't see, an invisible wind. First, let me introduce you to our hero. This is Sparky, a tiny, friendly, positive charge. And Sparky is just exploring the world, minding its own business. All of a sudden, Sparky feels a push, but it's not a normal wind. It's this invisible force that's pushing it around. Well, this electric wind is what physicists call an electric field. And this electric wind is a lot like a real wind. It tells us two things: how strong the push is and which way it's pushing. A strong wind means a big push. A weak wind, just a gentle nudge. The electric field works for Sparky in the exact same way. But Sparky's world isn't just about pushes and pulls. It's also about where you are. So now we're going to move from the idea of a wind to the idea of a landscape. As Sparky is wandering around, it starts to notice that some places just feel different. It's not a push, but it's like a kind of energy in the air. A feeling of having stored up energy just by being in a certain spot. This location-based energy is what we call electric potential. The easiest way to think of it is like a battery level. In some spots, Sparky has a full charge, but in other spots, it feels kind of drained. So here's the really important part. Electric potential is not about a push. It doesn't have a direction. It's just a number, an amount of energy Sparky has stored up, ready to be used. Think of it as an energy level, not a force. Okay, so we have an electric wind and an energy level. How do these two ideas even connect? Well, this is where our story gets really good. It's time for the most important part, the story of the hill. This one slide explains everything. Imagine Sparky is on a hill. The height of the hill, that's the electric potential. That's its energy level. But the steepness of the hill, right where Sparky is standing, that's the electric field. That's the push. So let me ask you this. Can you be on a really high part of a hill, but the ground right where you're standing is completely flat? Yeah, of course. Think about being on a high, wide plateau. You're at a great height, but there's no steepness, so there's no push. And there it is. That's the aha moment. This is the key to understanding all of this. High potential, being at a great height, doesn't automatically mean a strong electric field. They are connected, but they are not the same thing. So, how exactly are the hill's height and its steepness connected? Let's find out in our final chapter. It's pretty simple when you just think about the hill. The electric field is just how fast the electric potential changes. A gentle slope means a slow change in your height, but a steep cliff means a really, really fast change in height. So, it all comes down to this. The steeper the hill, the stronger the push. And that little formula there, that's just a math way of telling our hill's story. And what about that little minus sign in the formula? Well, don't worry about it. It just tells us something we already know from real life. If you place a ball on a hill, which way does it roll? Down, of course. It moves from a place of high potential energy to low potential energy. And Sparky does the exact same thing. So what's the moral of Sparky's adventure? What's the big takeaway from our story of invisible winds and these energy hills? Let's just break it down one more time. The electric field is all about a force, a push, that has a direction, just like the wind. Electric potential is all about energy, a level that has no direction, just like the height of a hill. If you remember just one thing from our story today, please let it be this. The electric field is the push. The electric potential is the energy level. It's really as simple as that. And that's the end of Sparky's tale. But it leaves us with a pretty fascinating thought, right? Now that you know the story of the hill, maybe you can start to see these invisible energy landscapes all around you, shaping our world in unseen ways.